Hello again everyone, and welcome back to my Linux Essentials series. In this series, one video at a time, I'll teach you foundational concepts around Linux, the things that I think that every Linux administrator should know as part of their job or even your hobby. In this video in particular, we're going to take a look at memory and swap usage. Now normally I go through one concept at a time in each video, but it's really hard to talk about memory and swap separately since they're so interrelated. So in this video, I'm actually going to cover both. More specifically, we need to understand how to tell how much memory we have available on our server, so that way we understand if memory is filling up and we need to take action, or if everything's okay. And also, what about swap? Sometimes it's highly debated when it comes to whether or not you need swap, but I'm going to throw that into this conversation as well, and it's going to be a great video. But before I get into that, I want to take a moment to mention the sponsor for today's video, Linode. Linode is a Linux-focused cloud server provider, and using their platform, you could actually set up your very own Cloud Linux server in minutes. You could use Linode's platform to set up your own blog, perhaps a Nextcloud server, a Minecraft server, but if you're not feeling particularly creative today, then you can actually use their platform to spin up a Linux instance that you can use while going through the tutorials in this series. In fact, they have all kinds of distributions available, so if it's covered on Learn Linux TV, then you could probably find it on Linode. And best of all, cloud servers on Linode's platform are very inexpensive. You can get started with a Linux instance for just $5 a month, but it's even more affordable because if you use the URL that's on the screen right now, then you'll be able to set up your brand new Linode account with $100 in credit, and you can fit quite a few Linux servers within that credit. The credit is actually good for 60 days, and I highly recommend you check out Linode's platform because they are awesome. So definitely check out Linode's platform. I highly recommend it, and I really appreciate their continued sponsorship of Learn Linux TV. So without any further hesitation, let's go ahead and dive in. So right here on my studio PC, I have an SSH session open to 4 different servers. I actually just had this window open when I recorded a different tutorial, but since I left HTOP running, I might as well start there. HTOP is an application that I covered in a previous video, so check that out if you're interested in HTOP and how it works. But you could probably glean what it does just by looking at it. I mean, it's a resource monitoring utility. It's showing me how busy my CPUs are. You can see that I have 2 of those. It gives me the average of the CPU usage. I've added that meter myself. That's not normally there. There's more information in the HTOP video. Anyway, more relevant to our topic today is the memory usage. And judging by these numbers right here, you could tell that I have over 1 gigabyte of memory free. So if I didn't know any better, I would say that this server is probably fine. Memory is good. You could use HTOP. Video over. We're all set. Let's move on. Well, actually, one of the issues here is that HTOP is not always going to be on your server. Most distributions actually make it available for you to install. However, typically it's not installed by default. In some distros, such as CentOS for example, they don't even offer you HTOP in the standard repository, so you're not always going to have this available. So if we take this out of the equation then, how do we actually tell how much memory is actually free without having to install any third-party utility? Well, that brings us to the first command in today's video, the free command. The free command tells you how much memory is free. So when you execute it, you'll have all the information you could ever want to know about how much memory your server or workstation is actually using. Now, I don't know about you though, these numbers right here aren't the easiest to understand. One thing that I do want to show you real quick is that those numbers are actually a bit easier to understand if we execute free-m. Well, the numbers are certainly smaller, but what free-m allows us to do is show the memory usage in terms of megabytes. And that's actually a lot easier for me to read. But now that we know to use the free command to find out how much memory is free, which value is the one that we should pay attention to? Should we pay attention to the free field, the available field? Maybe we need to look at the used field and do some calculation based on that. How exactly are we supposed to digest this information right here? I mean, if we look at the free field here, we have roughly 189 megabytes free. So if this is actually the number that we need to pay attention to, well, things don't really look all that good, do they? But thankfully, it's this number right here that we want to pay attention to. This number tells us how much memory is available. So we have 1,040 megabytes available to us right now. So, wow, I'm relieved because I was thinking right here that we had 189 megabytes free, but since we actually have over 1,000 free, well, I think I'm pretty comfortable. But anyway, the first takeaway of today's video is that under the available field, that tells us how much memory is actually free, and that's the number within the output here that we should pay the most attention to. And actually, you could probably argue that I could stop the video right here and send you on your way. Use the free command and pay attention to the available field, and that's all you need to know. Well, actually, there's more to the story than just that. But when it comes to memory management on a Linux system, that's quite the rabbit hole. There's a lot of information there, a lot of detail. Now, while you could dive right into that rabbit hole and understand in greater detail all the ins and outs of memory management in Linux, I don't necessarily recommend that unless you really do want to dive in deep, and if that's what you want to do, then, well, I encourage you to do exactly that. But what I'm going to do in this video is give you some more basics to help you understand. I'm not going to go too deep into that rabbit hole myself, but there are other values on that screen, and we should actually understand what they mean. So let's go ahead and see a basic definition of what the other values mean in the output of the free command. Okay, so in this section, I'm going to assume that you want more information when it comes to what all of these fields mean right here. And again, I'm not going to go too deep into this rabbit hole. I'll give you the basics, and that should be good enough. And then if you want to explore in more detail how memory is managed in Linux, you could do that. But if nothing else, let's see if we could get a better understanding of what these individual values mean. Now, first of all, and I probably should have mentioned this earlier, right here we have the total amount of memory that's installed on the server. So we have about 4 gigs of RAM. It's always going to be a little less than what it actually is. I'm not going to get into why that's the case. It's not going to be that much different. So if you see a value of 3925 right here, you have 4 gigs of RAM. Again, there's reasons why it's showing a lower amount than what's actually installed, but we're not going to get into that in this particular video. Now, this number right here, that one's probably self-explanatory. It's telling us how much memory is being used. And, well, about 2.6 gigabytes or so is being used on this server at this time. But let's go ahead and tackle this confusion right here. I mean, we have 189 megabytes free, but then we have, at least as far as this output is concerned, 1040 megabytes available. But what's the difference between free and available? I mean, if somebody asks me if I'm free for dinner, I'm not going to answer, I'm free, but I'm not available. They'll probably give me a very funny look. Now, earlier in the video, I told you that the available field is the only one that you really need to pay attention to. And that is true. I didn't lie to you. I didn't mislead you. But that's also not the full story. Now, what I'm going to do is explain the difference. And in order to do that, I'm going to have to confuse you. And then after I confuse you, I'll then correct the confusion. So the confusing thing is that where you see right here, I have 189 megabytes free. That's actually true. That's how much memory I have free right now. All of the memory on the system is legitimately being used except for these 189 megabytes. But wait a minute, I just showed you that this field right here is actually showing you how much memory is available, and that's the only field that you should pay attention to. So why am I now telling you that all but 189 megabytes are actually being used at this time? Well, nowadays, it's important to understand that memory is thought of differently than it used to be. If you started using computers when I started using computers, or perhaps before that, then you would actually consider 189 megabytes being free out of 4 gigabytes to be a big problem. But that's just not how things are thought of anymore. Unused RAM is wasted RAM. I'm going to repeat that. Unused RAM is wasted RAM. And the reason why this is important is because if you have something in memory, it could be retrieved faster than it could be retrieved from the disk. So what a Linux system tries to do is cache as much as possible, or as much as what makes sense to cache, so that way what you might need or what you might access can be retrieved a lot faster because it's sitting in RAM rather than being pulled directly off the disk. And in addition to that, this concept is less of a burden to your disk, because if something is being retrieved from RAM and then written to in RAM before it's synced to the disk, then that means the disk is getting less writes overall, and that's going to help us maintain that disk and see if we can make it last a lot longer, because the less data that we write to the disk and then rewrite and then rewrite and then rewrite, the better the overall health of the disk. So what we'll do is we'll store data in cache, we'll retrieve it from cache, will write to the cache, and then at some point we'll sync that cache back to the disk. But what does that actually mean? Well, under the available field, we have 1040. That's how many megabytes are actually available. And that amount of memory is actually truly available. Sure, it consists of data that is actually sitting in RAM, basically a cache. It's being used, but if you launch an application and that application needs more memory, then the system will actually give it some of the memory from the available field right here. So it's pretty much the equivalent of being unused. I mean, it is being used. There's a cache in play here, but it's only used when it's not needed. And if it is needed, then the system will give some of that memory to the process that needs it. So in shorter summary, RAM that's sitting around idle not being used is wasted. So the system is trying to make good use of that memory by caching things, but it's actually being a team player. It's going to give that memory away whenever it's needed. It's not holding it for itself. It's just using it for right now. There's idle memory. Idle memory is wasted. Let's use it for something good. And that's exactly what it's doing. So even though the memory in the available field is legitimately being used, it's only being used because the system doesn't have any designated use for that memory as of yet. So it just uses it for the cache to make use of the RAM in absence of something better to use it for. Now the available field actually includes the amount from the free column as well. So when I mentioned earlier that the available field is the only one that you should need to pay attention to, I wasn't kidding. The available field is literally the total amount of memory that processes can get access to if they need memory. So yes, 1040 megabytes are legitimately available for use. In addition, there's also cache and buffers as well, and even some more complicated aspects of how memory is managed on a Linux system. But I'm actually going to stop my explanation of memory usage right here because what I've gone over in terms of memory usage is exactly what you should memorize and what you'll use on a daily basis. Let's move on to swap and discuss that. In my case, right here, I have 511 megabytes of swap that's available. That's my total available swap. And of that, I'm currently using 0 megabytes of that, which is actually a good thing. We want to use as little swap as we could possibly get away with. And the reason for that is because swap is slow. And I mean extremely slow. So slow, in fact, that we would rather nothing use swap if we can get away with it. But what exactly is swap anyway? You could think of swap as emergency memory. Let's say, for example, that you ended up using all of your 4 gigs of RAM. You have nothing free, nothing unavailable, nothing at all. At that point, the system's out of memory. And, well, being out of memory is a really bad thing. A Linux server can't function without memory, so if it runs out of memory, things are going to come to a screeching halt. But what swap does, swap is actually giving a temporary amount of memory that's available for emergency use. But the problem with swap is that swap exists on the disk, on the storage volume. And the storage volume is always slower than memory. That's why we have a cache. If you recall what I mentioned earlier about unused RAM being wasted RAM, well, the same concept applies. Things are being cached into RAM because it's just that much faster. But when we run out of RAM, then all we really have is the hard disk. And swap is how much of the hard disk or the storage volume can be used for stand-in memory. So basically, swap is something that we usually want to have, but we hope we never end up having to use it. Kind of like car insurance. When it comes to some Linux implementations, we might not have any swap available to us at all. One example of this is if you're running a Kubernetes cluster. Instances within a Kubernetes cluster will typically not have swap at all because it ends up working against the cluster. Now, that situation isn't very common. There's not very many apps out there that run better in the absence of swap altogether. But I bring that up just to let you know that there are some situations out there where you might not want to have swap at all. However, that's not the only reason why you might not have swap on a particular server. And another reason could be that the administrator that set up the server initially, if that person isn't you, might be oppositional against having swap. Some people out there are very adamant on this. They will let you know that swap is something you shouldn't have, you should run without it, swap is bad, it only hurts you, so just don't use it. But actually, there's no truth to that at all. And this is actually, believe it or not, a very common debate. In fact, pretty much every Linux community that I visited personally has had at least one topic that's debating whether or not you should use swap at all. Now, I'm going to end that debate right here. there's no reason whatsoever, unless the application, such as Kubernetes, requires you to be in the absence of swap, that you should actually, well, be in the absence of swap. So definitely make sure that you have swap in some form or fashion on your Linux server, because it might just save you if your server is going to otherwise come crashing to a halt in the absence of memory. But the thing is, the debate when it comes to whether or not to use swap actually kind of makes sense. Swap is bad. Like I mentioned, hard drives are slow. We don't want to use them for memory. Anything that you have in swap is going to be orders of magnitude slower. So yeah, it's true that swap is a bad thing. We hope to never use it. But again, we definitely want to make sure that we have it, so that way, if we're in a bind, maybe it's going to help us out. Now the thing is, even if there was some sort of truth when it comes to running without swap as having some kind of benefit, keep in mind that storage devices are a lot cheaper nowadays than they used to be. I mean, you'd be surprised what a $20 SSD can actually buy you nowadays. Storage prices have come down a lot. So in my case, I see no excuse whatsoever why an administrator can't spare 1 or 2 gigabytes for swap. I mean, are you actually so hard up on hard drive space that you can't spare a single gigabyte for swap? I highly doubt that's the case. Now, the thing is, like I mentioned, we hope to never use swap, but some applications will use swap a little bit. So using a little bit of swap doesn't automatically mean that your memory is running out. I mean, if you're using a lot of swap, then yeah, that's probably the case. But using a little bit of swap isn't actually unusual. But if you have no swap whatsoever and the application you're running is actually designed to use a little bit of swap, well, it won't be able to because you have no swap. So when it all comes down to it, even though swap is something that we really wish we never end up using, we really should have at least a little bit of swap. If nothing else, it might just save the day at some point in the future. So how exactly does a Linux server then calculate or make a determination as far as whether or not it should be using swap at any given time? Well, what I want to do right now is go over the existence of the Swappiness variable. Swappiness is a value that helps the system determine how much swap it should be using at any given time. And what I'm going to do is switch over here to server number 3, because this server has had the least number of custom configurations on my end. So it's going to be the most similar to a real server that you might see out in the wild. Anyway, let's see if we can grab the current Swappiness value for this particular server. It would be interesting to see what that number actually is. And to find it, we can run sysctl and then vm dot Swappiness, just like that. So I'll press enter, and we get a value of 60. Now, one thing that a lot of administrators will do is they will adjust this value to get the most performance out of their server that they can. That's something that I can cover in a different video. I'm not actually going to show you how to change this value in this particular video. And even if I did include that into this video, it probably wouldn't help you that much in the context of what I'm going over, because what you want to set the Swappiness value to depends on the workload or the application. I can't provide you with one value to use here that works across the board because every server is unique. If nothing else, 60 is considered a happy medium, so typically that's going to be the default value that Swappiness is set to on most distributions, or at least the majority of the distros that I've tried personally. Anyway, the lower the Swappiness, the less likely swap is going to be used. Now you might assume then that if you set this to 0, you're effectively disabling swap, but that's not actually true. With a Swappiness value of 0, that means that your Linux server will do everything in its power to never use swap if it can get away with it. It doesn't mean that it's never going to use swap. It just means that it's aggressively going to try to not use swap, but it's still going to use it if it absolutely has to. And I mentioned earlier that swap is technically a bad thing because it's going to be fetched a lot slower than if you fetched it from RAM. So I'm not actually telling you to set your Swappiness to 0, I just wanted to give you that metric. Again, there's no one answer here for what this value should be set to. It depends on your server and what types of processes are running on it. Anyway, that was a simple explanation of memory usage, how to read the memory usage, and also what swap is and why we generally don't want to use it, but we still have to have it while also debating whether or not we should be using it. Linux is very interesting to say the least. Anyway, in this video, we took a look at memory usage, also how swap factors in. So hopefully this video was helpful in teaching you the basics of memory usage and how to understand how much memory is being used. But keep in mind, Memory management in Linux, like I mentioned earlier, is a rabbit hole, a very, very deep rabbit hole. It's a fun rabbit hole if you're into computer science, but if you're not, then what I've gone over in this video should probably be enough for most of you. Anyway, let me know what your thoughts are in the comments down below. If you found this video helpful, please click that like button, and I'll see you in the next video as soon as I have it uploaded. Thank you so much for checking out this content, and I hope you have a great day.